Hello and welcome to this video tutorial about scenProc. In this video tutorial I want to talk about a new feature that I've recently added to create 3D buildings in scenProc. So let's have a look at some data of building footprints. Here you see a small bit of a town somewhere in the Netherlands. And when you want to represent these buildings in your scenery, you can use AutoGen buildings, of course. That is the typical approach if you want to add buildings to a big area. But as you probably know, the AutoGen buildings have to be rectangular in shape, and you can see that many of the buildings here are not perfectly rectangular. So that either means you'll have to fit a rectangle around the building or try to split it into multiple rectangles, or some of the more complex shapes are just skipped because they can't easily be represented by rectangles. So if we look at some AutoGen buildings created for this area, you can see that quite a few of them can be represented with rectangles. A couple of them are being skipped because they're too complex in shape. And if we now look in the sim how that looks, you get an area of your scenery populated with buildings, which looks quite nice. Um, but but you're missing the more natural, more complex shapes. And another issue you can see here, some of those houses in the middle, they're a bit too tall for the size of the footprint. It's probably more realistic to have a one floor building there. But with AutoGen, you can't control the height of individual buildings. So wouldn't it be nice if there was another way to generate those buildings? And that's what I've recently added to scenProc. So I'll jump to the menu of the tool now. I've added a feature that can create 3D buildings, and it creates them as MDL files, so the typical model files for Flight Simulator, which are then placed in your scenery. And the algorithm can, it takes your footprint, then extrudes the walls and adds a roof to it to give you your building. There are a couple of roof styles that are supported in these buildings. Of course, you could do a flat roof for the most simple buildings. You can do a hipped roof, or you can do a gabled roof, as you see here. And there are a couple of special features as well. Um, for example, if you have a gabled roof, like you saw here, you can do a modification to the footprint so that you can add a third gable to it. In some countries and some regions, this kind of extra gable is typical in the architecture, so then it's nice that you can represent it in your buildings as well. And another example of such a modification is shown here. This is a more like a L-shaped building, and normally you would get the gables at the begin and the end of the L. But with the additional modification, you can have a third gable over here, sort of opposed to that one, which is a nice way to get a bit more variation in how the building looks. As you can see from these pictures, the buildings are relatively simple, and the roof styles also. That's done on purpose to keep the polygon counts low so that you can add quite a few of them to your scenery without running into performance issues. So this is the kind of buildings that scenProc can make, and I will first show you how you can do that from the script. To create those buildings, you use the Create 3D Building step, which takes a couple of arguments. The first one is the filter that selects which features you want to create the buildings from. In this case, I just loaded some OpenStreetMap data that I just showed you in QGIS as well. I'm selecting the buildings from there, and then all the buildings that have less than 7 vertices, I give a gabled roof. Buildings that have between 7 and 11 vertices, I give a hipped roof. And ones that are even more complex, so have more than 11 vertices, I give a flat roof. That's of course a very simplistic schema to classify the roofs. You can probably come up with something more realistic and better looking, but this serves the demonstration here. So the first argument selects the features that the building should be created for. Then the second argument is the height of the building. And you can enter two values like you see here, then scenProc will automatically randomly pick a value between those two values. So in this case, I told it to make buildings that are between 3 and 6 meters in height. Then the next argument is the altitude. I want my buildings placed on the ground, so I give it a 0 here. Then we have the roof type, in this case the gabled roof. Next, I can specify the slope of the roof. And just like the height, I can enter two values here. So in this case, this means that the slope of the roof is between 25 and 40 degrees. The none here is the additional modification. Like I showed in the manual, you can have additional modifications to add more gables. You can specify here which one you want to use. And then the next argument is the building texture configuration file. That's the configuration file that helps scenProc to determine how the texture should be applied on the building and which texture should be applied. We'll have a closer look in how this configuration file works and how you can create it later on. And then the last argument is the roof group, because the roof textures can be divided into groups and you need to tell the scenProc which group you want to use for this building. The other two lines are basically the same. I have a different roof type and a different filter, but that's all. And then at the end, when all the buildings have been created, there's the export BGL step, which creates all the model files and saves them into a BGL file. So let's just run this script. And now scenProc has to, actually creating the buildings is relatively quick, but saving all the model files with X2MDL, that takes a little bit of time. So you see here that it's compiling all the various models. And okay, now it's done with compiling. So let's first have a look in the sim how it looks. Here's my new file. I will remove the AutoGen file so that we don't have the AutoGen buildings in between as well. And then I'll just reload my scenery library in Prepared to have a look how the new buildings look. So let's give it a second to reload. Okay, there we are. And here you see now there are the model buildings placed in the scenery, where you can see that we have much more variation in shapes. It matches the footprints polygons a lot better. We have different roof styles. We have different wall textures. I will explain where they came from later on. We have different roof textures. So this gives I think a much nicer variation of buildings in your scenery. So that was how you can create them, but of course for how they look, the textures of the building is a very important aspect. So let's have a closer look at that bit, because in the script you just point to a texture configuration file, but how do you create one? If you go to the Tools menu, you can select the Building Texture Configuration Editor, and in this editor you can create and manipulate that building texture configuration file. This editor has a couple of areas. On the left, you see a list of the different wall textures in your configuration file. And if you have more than one wall texture, then scenProc will randomly pick one from the list and use that for the building. So the more segments you add here, the more variation you get in your wall texture. And down here, the same for the roofs. You can get a list of different roof textures here. And roof textures can also be grouped, so they can have a group. And that's the group you specify from the script when you when you load one, when you select which group to use. Those groups can, for example, be used if you want to have dark colored roofs and lighter colored roofs, so that you can add more variation to that, and maybe you have some attributes in your data that help you to pick the right color. So that's why the groups have been added. And then here on the right side, you have the properties of the texture segment. So let's just add a wall texture. You select the file that you want to use for the texture, and here you see sort of my dummy test texture, which you saw in the sim before as well. This is a texture sheet that has 3 different wall segments and 2 different roof segments. So now we added the first wall segment, and let's say we want to configure this blue segment here in the middle. So first we need to tell scenProc which bit of the total texture is my wall, and that is done with the size properties here. So that's the size compared to sort of relative to the total texture size. So you can see this one is the full width but a quarter of the height. So I'll change the size in the y direction to a quarter, and seen from the bottom it's also a quarter up, so I give it an offset of a quarter as well. And if I then reload the texture, you see now we have my wall segment, and I could repeat these steps and add the other 2 wall segments as well. So now scenProc knows that this is one wall that it can apply, but of course it also needs to know how to scale this texture on the building. So for that you need to tell it what the maximum length is that this texture should be applied to. So basically the full length here, how many meters on the building is that? And in this case, the texture has been designed for around 32 meters. But if you design your texture at a different resolution, you can specify here what the scaling should be, and then scenProc can map it with the right scaling on the building. And also if the building is longer than this length, it can split it into different wall segments so that each of them can get a texture. Now, of course, when mapping this texture on the building, there's some other things that we need to do, and one of the most important is to prevent that the doors and the walls and the windows that you see here are being sort of clipped on the edge of a wall segment. It looks very unrealistic if you have half a wall or half a door. But for that you need to help scenProc a bit, because you need to tell it where the doors and the windows are. So if I click here the add window mode, I can draw the rectangles around the windows, and then when determining the texture mapping, scenProc knows where those windows are and can avoid putting them clipping them on the edges of the wall. So I have to do that for the whole texture segment. I only do a couple of windows here now. Sometimes you also want the windows to not be directly next to the corner. You might want to have them like half a meter or so from the corner. You can do that by setting an additional window offset, which is specified also in the sort of relative texture width. So I give it a 1% offset here. And you'll now see that there's a dashed line around the windows, so that the dashed area now will be sort of kept away from the edge of the walls as well. Typically this gives a better looking result. So this you have to repeat for the whole texture. I'll be a little bit lazy and I'll load the finished one. So here you see the total texture where I've mapped all of the windows on it. And you'll also notice this yellow line here probably. That yellow line is another feature that specifies which bit of the texture is the ground floor, and which bit are the other floors of the building. Because on the ground floor here we have a couple of doors, for example. And if my building is taller than 3 floors, as you see here, then the texture needs to be repeated vertically as well, of course. But it would look very weird to have doors somewhere on the 4th or 5th floor of your building. So then the segment below the yellow line is not used. So when the texture is repeated vertically, only the top bit, the top 2 floors are used, and that gives a more realistic result. If you look at some of those other texture segments, you can also see maybe that the ground floor has a very different color, and then also it would look weird to repeat that upwards. So that's why you can specify the height of the ground floor, and that's shown with this yellow line. And you can specify it here in the properties. So then we have had the offset, the size, the window offset. The only property left is the windowed gable percentage. When you're making gables, scenProc can do two things. It can try to map one without any windows on it, so then it will try to find an empty piece of texture, like any of those areas maybe, and then map that on the triangle of the gable. You can also tell it to try to map a window on it, and then it will try to find a window that fits in the middle with enough empty space to map that on a triangle. So that could be done here, for example. And this property is used to specify which percentage of the gable should have a window. So if you put it on 1, it will try to put a window on every gable. If you put it on 0, it puts no window on any gable. And if you do it in between, it will randomly select one. So that's basically what you do here. So you add the different wall segments. You all specify where the windows and the doors are. Same goes for the roofs. So I have different roof textures here. I've grouped them in one group, in this case any, but you can make different groups if you want to use that feature. And that's basically what there is to say about making the building texture configuration. Or maybe one thing that's still nice to illustrate here at the bottom, you see a sort of a quality indicator of your texture. So we'll start with the top one that shows how easy it is for scenProc to map this texture on a building of different length. So here on the horizontal axis, you go from 0 meters to 32 meters, which is the maximum segment length. And then the colors indicate how easy it is to map this texture. So for example, on a relatively short wall of maybe around 4 or 5 meters, you see the color is a bit red. And that's because it's difficult to find a segment of the texture here that is so short, but without clipping any of the windows. You will see if we make the window, if I sort of remove the window offset, then it becomes a lot easier to map the textures. So this indicator will help you to see if your texture is sort of flexible enough to be mapped on different buildings with different wall sizes. The vertical axis is sort of the vertical variation in the texture. So here you see that the bottom part is more difficult to map because that one has more windows, but the upper part is more green in color, and that's because it has more open area, so that makes it easier to map the texture. And then this second quality indicator is about the gables. So if you want to have a gable without any windows, this color indicates if scenProc can find one or not. And that depends on the length of the gable as well. Of course, if you have a very long building with a gable, then the gable, depending on the slope, which you see here, by the way, this is the slope, so from 0 to 60 degrees. If you have like a 32 meter wide gable with a 60 degree slope, then actually you would need, the triangle would be bigger than this texture. So that's why the color is red here at the top. It won't find an empty bit of texture that's big enough for that. But this gives you an indication how likely it is that scenProc will be able to map a gable correctly on the building. And the bottom one is kind of the same, but it shows how easy it is to map a window on the gable. And you see here that it's basically only possible for certain slopes and certain width of the gable to map a window on it. And that's probably because this is the only window in the texture that's suitable. So if the gable gets too wide, you will run into this window, for example. But these quality indicators should help you to optimize your texture and make it as flexible as possible. So that's all I wanted to show about this new feature. If you have any questions about it, feel free to post them on the forum. And I hope you found this tutorial useful.